students, in nitro compound lesson, in this video we are going to learn chemical properties of nitroalkane, chemical properties of nitrobenzene and classification of amines, IUPAC name of amines, structure of amines. Rest of the lesson in PPT.
In this slide, we are going to see the chemical properties of nitroalkane. First one, reduction of nitroalkane. What is reduction? Removal of oxygen and addition of hydrogen. See the example, nitromethane. First of all, here we are going to add hydrogen, but the hydrogen taken away one oxygen, so that 1 mole of water removed, we get nitrosomethane. Then once again that nitrosomethane is added with 2 hydrogen, so that we are getting N-methyl hydroxylamine. In this N-methyl hydroxylamine, you see the formula, the nitrogen is added with contain methyl. So nitrogen is attached with the methyl, so N-methyl, and also that nitrogen containing OH, that is the amine NH2 group containing OH as well as methyl, so that N-methyl hydroxylamine. Then once again the N-methyl hydroxylamine is added with the hydrogen, it taken away one oxygen, so that 1 mole of water removed, we get methylamine. The next one, when nitromethane is added with tin bar HCl, based on the pH of the medium, we get methylamine. How it is means that 6 hydrogen is added, that 6 hydrogen, 2 hydrogen is added with the nitrogen, so that we get methylamine, and 2 oxygen is removed, the 2 oxygen is combined with the 4 hydrogen, it gives 2 mole of water. It is happen in acid medium. The next one, if it is in the neutral medium is zinc bar ammonium chloride. Here 4 hydrogen is added. I split the 4 hydrogen, 2 hydrogen and 2 hydrogen. Then 2 hydrogen combined with 1 oxygen of nitromethane. It gives 1 mole of water, and remaining what we are having CH3NO. That NO is added with 2 hydrogen, means we get N-methyl hydroxylamine. The next one, alkyl nitrite. Here the nitromethane, alkyl nitrate means nitroethane. Nitroethane isomerism what we are having means that ethyl nitrite. The ethyl nitrite undergo same way reduction with the help of 10 per HCl. Here also 6 moles of hydrogen is added. That 6 moles of hydrogen is split into hydrogen. That one of the hydrogen is added with the oxygen. So with that CH3CH2O, H means ethanol, and the nitrogen, one of the nitrogen is added with the 3 hydrogen, we get ammonia, and one of the oxygen is added with the 2 hydrogen, we get 1 mole of water. Hydrolysis of nitroalkane. The primary nitroalkane gives carboxylic acid. See the first example. Nitroethane is the primary nitroalkane. In that one, we are going to boil HCl bar H2O. Here the H2O is in between that nitrogen and hydrogen, indicated in brown color, so that we get hydroxylamine. Remaining things what we are having, CH3C and H. In between the H we put 2 oxygen, means we get acetic acid, and that HCl we are getting as the one of the product. Then second one, the 2-nitropropane. 2-nitropropane is the secondary nitroalkane. We are going to take 2 mole of 2-nitropropane. In that one, the same way HCl bar water we are going to boil, means that brown color I strike to hydrogen, and then 2 nitrogen I strike it. That means 2 nitrogen is taken away, the 2 nitrogen is added with one of the oxygen, then the 2 hydrogen also one of the oxygen, means remaining thing what we are having means CH3C double bond O, the 2 mole of acetone we are getting, and then nitrous oxide, N2O means nitrous oxide, and H2O means water. The next one, tertiary 2-methyl 2-nitropropane. It is a tertiary nitroalkane. This one is boiled in presence of HCl or water, there is no reaction. That means it never undergo hydrolysis reaction. The next one, ethyl nitrite. It is in the form of isomerism form of nitroalkane. Ethyl nitrate undergo hydrolysis. That hydrolysis is water split into HOH. That one of the H goes to O, I indicated in blue color, so that we get ethanol. Remaining thing what we are having means N double bond O OH, that is combined, that we get HNO2, that is nitrous acid. Halogenation of nitroalkane. Nitroalkane, which one having alpha hydrogen atom, that is replaced by halogen atoms in the presence of sodium hydroxide. See the example, CH3NO2 means nitromethane. In this nitromethane, the nitro group is functional group. The nearer carbon is called as alpha carbon. The alpha carbon containing hydrogen are called as alpha hydrogen. How many alpha hydrogen is here? 3 hydrogen. That 3 hydrogen is replaced with 3 chlorine, so we get CCl3NO2, that is chloropicrin. Another name is trichloronitromethane. The next one, toxicity. That nitroethane is cause genetic damage, and also it is harmful to our nervous system. Then another one, when the nitroethane is added with the potassium hydroxide, it undergo isomerism. See that one of the hydrogen in blue color, that is moved to oxygen. That the double bond is replaced to the second carbon, nearer nitrogen nearer carbon. So we get CH3CH double bond N, single bond OH, and single bond O minus. Again it is added with the water, we get ethanol and then hydroxyl amine. Then see that ethanol CH3CH double bond O, the double bond O containing oxygen. The remaining things, NOH is added with the water, so we get NH2OH, that is hydroxyl amine. Chemical properties of nitrobenzene. The first one, nitrobenzene is added with the 10 power HCl. Here 6 mole of hydrogen is added. It is split into 2 hydrogen and 4 hydrogen. I split it into 2 hydrogen, 4 hydrogen. Then 4 hydrogen taken away to oxygen. So we get 2 moles of water removed. Instead of the 2 oxygen, 2 hydrogen is added. We get aniline. The next one, the nitrobenzene is added with the zinc bar ammonium chloride. It is called as neutral medium. In that one, 4 hydrogen is added. I split it into 2 hydrogen and 2 hydrogen. One of the 2 hydrogen taken away, 1 oxygen. So 1 mole of water is removed. Instead of that 1 oxygen, we are going to add 2 hydrogen. So it gives phenyl hydroxylamine. The C6H5 is called as phenyl, and NHOH is called as hydroxylamine. The next one, nitrobenzene is added with the iron bar water. It is also called as neutral medium, but zinc bar ammonium chloride we added 4 hydrogen, but in the iron bar water we are going to add 2 hydrogen. The 2 hydrogen taken away 1 of the oxygen from nitrobenzene, so that 1 mole of water is removed. Remaining what we are having means C6H5N double bond O, that is called as nitrosobenzene. The next one, 2 mole of nitrobenzene is added with the tin chloride bar potassium hydroxide. One of the nitrobenzene is one of the nitrobenzene, the 2 oxygen is removed. Instead of 2 oxygen, 2 hydrogen is added, mean we get aniline. And another mole of nitrobenzene, the only 1 oxygen is removed, so we get nitrosobenzene. Now once again, that aniline and nitrosobenzene, I indicate in red color, that hydrogen and then oxygen removed means remaining we added, we get C6H5N double bond N, single bond C6H5, that is azo. Azo means the 2 nitrogen is called as azo, and then it contains benzene, so that it is azobenzene. The next one, again 2 mole of nitrobenzene is added with the zinc bar sodium hydroxide. First of all, it give the azobenzene like the previous product. Again it undergo Reduction means addition of hydrogen and give the hydrazobenzene, that is C6H5 NH bond NH bond C6H5, that is called as hydrazobenzene. Electrolytic reduction. Nitrobenzene undergo electrolytic reduction in two ways. In the first way, what is reduction means? Addition of hydrogen, removal of oxygen. Here we are going to remove two oxygen. Instead of two oxygen, two hydrogen is added, so we get aniline. C6H5NH2 name is aniline. And removed oxygen, two oxygen combined with the four hydrogen, it gives 2 moles of water. Then another path, 4 hydrogen is added. In that one, 4 hydrogen means only one oxygen is removed, so it combined with the 2 hydrogen, it gives 1 mole of water, and remaining 2 hydrogen is added with the nitrobenzene. We get phenyl hydroxylamine. That the phenyl hydroxylamine is the one of the product, and another product, the OH is shifted to para position during this electrolysis, so that we get para aminophenol is the another product. The next one, the reduction in the presence of catalyst or metal hydride is take place, means we get the product aniline. Aniline we are getting by removing 2 oxygen in nitrobenzene. Instead of 2 oxygen, we are introducing 2 hydrogen, means we get aniline as the one of the product. The next one, selective reduction. Selectively that reduction processes take place by polynitro compound. That ammonium sulfide is added with meta-dinitrobenzene. The meta position nitro alone changed into aniline, and that NH2. So that is called as meta-nitroaniline. Benzene with the NH2 is called as aniline, and here that NO2 is selected as meta position, so that meta nitroaniline, and then we get the byproduct of 6 moles of ammonia and 2 mole of water and 3 mole of sulfur. Electrophilic substitution reaction of nitrobenzene. The electrophile is substituted. Electrophile means it is a positive character or it may be a neutral character. So the electrophile is substituted in the nitrobenzene. Under the it is a very slow process, and then vigorous condition only take place. The nitro group is a strongly deactivating groups, and also it direct the incoming group in the meta position, so it is a meta directing group. First example, when the nitrobenzene is added with the chlorine in the presence of aluminum trichloride, the aluminum trichloride alone polarize the chlorine as Cl plus and Cl minus. One of the Cl plus is the electrophile, because it is a positive character, it needs the electron, so the nitrobenzene contain more electron, so that Cl plus is directed towards the nitrobenzene. Then the nitro is the meta directing group. That meta directing group directed the Cl plus to meta position, so we get 3-chloronitrobenzene. And the chlorine is in the third position, nitro is the first position, so 3-chloronitrobenzene we get the product. Here the meta position containing hydrogen, that hydrogen is replaced, and then chlorine is substituted, so that it is called as electrophilic substitution reaction. The replaced hydrogen is combined with the Cl minus, we get HCl is the one of the product. The same way, the nitrobenzene is added with the concentrated nitric acid in presence of concentrated sulfuric acid. The concentrated sulfuric acid polarizes the nitric acid as NO2 plus and OH minus. The NO2 plus is the electrophile, it is directed to the nitrobenzene in the meta position, so we get 1,3 dinitrobenzene. The next one, nitration under the temperature 473 Kelvin. In the previous one 373 Kelvin means only one nitro group is added in the meta position, but in 473 Kelvin another NO2 also it is placed in the another meta position, so that we get 1,3,5 trinitrobenzene. If we put the number means we get 1,3,5 trinitrobenzene. And sulfonation. Sulfonation means concentrated sulfuric acid is added, means that concentrated sulfuric acid split into SO3 and H2O. That SO3 is a neutral electrophile, that is it contain empty orbital. That empty orbital attract the electron from the nitrobenzene, so that the nitro group directed the SO3 in the meta position. So in the SO3 it is a minus character, it attract the removed hydrogen, so that it now SO3H. What is SO3H means? It is a sulfonic acid, 3-nitrobenzene sulfonic acid. If you put the number 1 for SO3H means the nitro position is 3, changed as a 3, so 3-nitrobenzene sulfonic acid. Nitrobenzene, it does not undergo Friedel-Crafts reaction, because we already see that nitro group is a strongly deactivating group. Because of the deactivating nature only, the nitrobenzene does not undergo Friedel-Crafts reaction. Then next one, evaluate. In your book it is given in the page number 209. The first question, when that methyl benzoic acid is added with the concentrated sulfuric acid, concentrated nitric acid, we get the product. Here the nitric acid, now only we saw in the previous slide, the nitric acid split into NO2 plus OH minus with the help of sulfuric acid. The NO2 plus is the electrophile, it is directed into the meta position, so we get the product in the meta position. Acid with the meta position means the fifth position is the meta position. See the diagram. So the first one is acid, third one is methyl, and fifth one is nitro. So 3-methyl 5-nitrobenzoic acid. Next one, in the second one, that orthonitrotoluene. Here also the concentrated sulfuric acid, concentrated nitric acid is added, means we get the nitro from the nitric acid. The nitro is added to the ortho of the methyl group. Methyl is the position is number 1. Already we have one nitro in second position, and another nitro is added with the sixth position, that is called as ortho position. Then another one major product, the another nitro is added with the fourth position. That fourth position is it is opposite position of methyl, that is para product. So we get the major product here. Here the methyl is ortho and para directing group. Which one is incoming now? That nitro is the incoming group. The nitro group is, first of all, it is added with the ortho position and also with the para position. The para position product is a major product. Why it is not a ortho position? Means ortho position containing so much of crowded atoms in the one side, but that para position, that position of that groups are in opposite direction, it is balanced, so that always the para product is the major product. The next one, third one, here 2,4,6 trinitrotoluene. Here we are going to add soda lime or acid bar sodium dichromate. That decarboxylation take place. Decarboxylation means that carbon is removed, the methyl is removed, and then we get the product 1,3,5 trinitrobenzene. You see the number, that is first position, second, third position and fifth position we are having nitro, so it is a 1,3,5 trinitrobenzene. Amine. What is amine means? It is a derivative of ammonia. Ammonia formula NH3. Instead of one hydrogen, if you add alkyl group means we get the amine. That amine is classified as aliphatic amine or aromatic amine. Instead of hydrogen, if we add alkyl group means we get aliphatic amine. Instead of hydrogen, we add aromatic means aryl group means we get aromatic amine. First one, aliphatic amine, it is classified as primary amine, secondary amine, tertiary amine. In primary amine, the nitrogen containing only one alkyl group. In secondary amine, the nitrogen is attached with two alkyl group. And tertiary amine, that nitrogen is attached with three alkyl groups. Then same way in aromatic amine also there is three amine: primary, secondary and tertiary. Here also the nitrogen is added with one aryl group means it is primary, two aryl group means secondary, three aryl group means it is tertiary. Primary amine means the nitrogen containing only one alkyl group or one aryl group. See the example: the nitrogen having CH3 CH2 only one alkyl, that is ethyl. That name of that compound 2 carbon eth single bond ane and amine, so ethanamine. And here aromatic amine, see the example: aniline, common name is aniline. The nitrogen is containing only one aryl group C6H5, and IUPAC name, the C6H5 is benzene and single bond ane, and then amine, benzylamine. The secondary one, in this one it is split into two: simple and mixed. Simple means the amine both the side having same alkyl or same aryl means it is simple. Mixed means the nitrogen one side having one type of alkyl, next side another type of alkyl means it is mixed one. Now see the simple. First example: NH is contain CH3 CH3. The first one, the CH3 first carbon, only one carbon is there, so meth single bond ane, and then it contain amine, methanamine. Then another side the nitrogen is bonded with methyl, so that we have to write N-methyl methanamine. Then aromatic side, you see that the NH is containing 2 C6H5. One of the C6H5 we have to take as a root word benzene, and then amine, benzenamine, single bond is there, so benzenamine. And that nitrogen is attached with the phenyl, so N-phenyl, the C6H5 now called as phenyl, N-phenyl benzenamine. The next one mixed. For mixed secondary amine, see the first example. Here the NH is one side is added with the CH3, another side is added with the CH2 CH3. The CH2 CH3 is containing 2 carbon, so we have to take this one is a root word, so eth single bond ane, and then amine, so ethanamine. The NH before that we have CH3, green color I indicated. That methyl is attached with the nitrogen, so we have to write N-methyl ethanamine. The next that aromatic amine side, see that C6H5NH bond CH3. Here one side methyl, another side is phenyl. Which one we have to take as a root word means the methyl alone we have to take root word. Methyl containing one carbon, so one carbon means meth single bond ane, and amine is there, methanamine. And remaining we are having the nitrogen, it attached with the C6H5, that is called as phenyl. We have to write N-phenyl methanamine. Always in amine, the nitrogen attached what alkyl group or aryl group we have to write as N-methyl, N-phenyl, like that we have to write. Tertiary amine. In the tertiary amine also two types, one is simple, another one is mixed. In the under the simple aliphatic amine, see that around the nitrogen we have 3 methyl, same one, so that is a simple one. One of the methyl I have to take as a root word, I indicated in brown color, so only one carbon is there, so meth single bond is there, and then amine, so methanamine. And the nitrogen is attached with the 2 methyl, so we have to write as a N, dimethyl. We always indicated 2 nitrogen. For only one methyl group is added means only one nitrogen, but here 2 methyl is attached with the nitrogen, so we have to write as a N, separately it is attached with the nitrogen, so that we indicated that N, N. The same way in aromatic amine, around the nitrogen we have three C6H5. We have to take one of the C6H5 as root word. We mentioned here brown color. The C6H5 is called as benzene now, and then single bond ane, and then amine, benzenamine. And the nitrogen remaining 2 phenyl is attached with the nitrogen. Separately we write N, diphenyl. So name of that compound is N, diphenyl benzenamine. The next one mixed. In that one, around the nitrogen, you see the first example in aliphatic amine. one side is CH3, that is methyl, another side is CH2 CH3, that is ethyl, and another side CH3 CH CH3, that is propyl. So which one we have to take as a root word means the green color indicated there is 3 carbon. 3 carbon means it is a large number of carbon, so we have to take as a root word prop and single bond ane propanamine, and remaining one side methyl, one side ethyl is attached with the nitrogen. Separately we write as n-ethyl, n-methyl before the root word, so that the name of that compound is n-ethyl n-methyl propanamine. The next one in aromatic amine, you see that the nitrogen around the nitrogen, one side C6H5, one side methyl CH3, another side ethyl CH2 CH3. Now which one is root word means the CH2 CH3 is a root word because it containing 2 carbon. When compared to the aromatic and alkyl means we have to take a alkyl as a root word here, so that we are taking these 2 carbon as a root word. So 2 carbon means eth, single bond ane, and then N means amine. Don't think that nitrogen, N means nitrogen. Even N also amine, NH also amine, and NH2, don't see that NH2 alone amine. NH2 means it is a primary amine. NH means it is a secondary amine. The simply N means it is a tertiary amine. Now we are seeing the tertiary amine girls, so that now see that the 2 carbon is eth and single bond ane and amine ethanamine. Remaining the nitrogen is attached with the phenyl as well as methyl. So root word before the root word you write as n-methyl n-phenyl ethanamine. The first one, it is a isopropylamine. Common name is isopropylamine. There is 3 carbon is there, so prop single bond ane. In the second carbon it containing amine, so that propane 2 amine. The next one, it is a allylamine. Common name is allylamine. The indicated number, the first carbon containing amine, and in second carbon double bond is there. 3 carbon means prop, so double bond in the second carbon to 2 ene, and first carbon containing amine, so 1 amine. So name is prop 2 ene 1 amine. The next one, hexamethylene diamine. CH2 is called as methylene, and how many methylene is here means 6, so that it is hexamethylene, and 2 side is amine having, so that diamine. Common name of this compound is hexamethylene diamine. Now we are going to see the IUPAC name. How many carbon bracket, inside the bracket we are having 6 carbon, so that hex, and then there is no double bond. If it is double bond means they will indicate, but there is no indicator means it containing single bond only, so that ane, X ane, and then that first carbon and last carbon containing 2 amines. If you expand this CH2 means the first carbon and the last carbon having 2 amine, so that we have write 1,6 diamine. So name of this IUPAC name of this compound is hexane 1,6 diamine. The next one, methyl isopropylamine is the common name for this compound. Now we are going to see the IUPAC name. I put red color 1, 2, 3. The second carbon containing amine, and 3 carbon means prop, single bond ane, and second carbon containing amine, so 2 amine. See the IUPAC name. First of all we have to choose the root word. What is the root word here? Prop is the root word. Afterward single bond ane, propane, and then second carbon having amine, so 2 amine, propane 2 amine. Now that NH in the left hand side we have CH3, that is methyl. The methyl is attached with the nitrogen, so that we have to write the N-methyl as a prefix to the root word. So N-methyl propane 2 amine is the IUPAC name for methyl isopropyl amine. In this first one, it containing 2 ethyl and another side 4 carbon means butyl. So diethyl butyl amine is the common name. The first for that we are going to see the IUPAC name. I put the red color. How many number is there? 4 carbon. So 4 carbon means root word is but and single bond ane. and the first carbon containing nitrogen, even nitrogen also we have to consider as a amine girls. So butane 1 amine. Then the remaining nitrogen containing separately it is attached with 2 ethyl, so that we have to separately write n comma n diethyl in the prefix. So the what is the IUPAC here means n comma n diethyl butane 1 amine. The next one, ethyl methyl isopropylamine. That nitrogen one side containing CH3 methyl, another side C2H5 ethyl, and another side 3 carbon it is a isopropyl. For that we are going to see the IUPAC name. I put the red color number, see the red color number. 3 carbon is there, so probe is a root word and single bond ane. In the second carbon it has the nitrogen, so 2 amine. Then remaining the nitrogen separately attached with the methyl and then ethyl we have to write in a prefix. So N ethyl, N methyl propane 2 amine is the IUPAC name. The next one, N comma N dimethyl aniline. Aniline formula is benzene attached with the NH2 means it is a aniline. Here the nitrogen is replaced with the 2 methyl. NH2 containing that hydrogen replaced with 2 methyl means we get the N comma N dimethyl benzene amine. The benzene is a root word here, and the benzene containing nitrogen is called as amine, so benzenamine. The nitrogen is attached with 2 methyl separately, so we have to write N comma N dimethyl benzenamine. The first compound common name is benzylamine. For that benzylamine we are going to see the IUPAC name. The benzene as well as aromatic aliphatic means which one we are going to take as a root word means the aliphatic one. So here the blue color CH2 is containing 1 carbon, so meth and single bond ane, and it contain amine, so that methanamine. And that benzene ring is we have to take as a phenyl. That phenyl we have to write before the root word. So phenyl methanamine is the IUPAC name for this compound. The next one, N-methylbenzylamine. For that IUPAC name, indicated blue color. That blue color is we have to take as a root word. Blue color containing how many carbon? Only 1 carbon. So meth and single bond ane. And the remaining thing, we have the amine. That amine containing CH2. That CH2 is we have to say methyl, and then the methyl is attached with the phenyl, so that it is called as methylphenyl. That methylphenyl attached with the nitrogen, so N methylphenyl. Please remember that we never separately write N phenyl N methyl, it is a wrong one, because the nitrogen directly attached with the methyl, that methyl alone attached with the phenyl, so we have to take it as a only one compound, that is methylphenyl. So N methylphenyl methanamine. Neopentylamine. Around the carbon, the 4 carbon is aliphatic amine means that is alkyl group containing means that is called as neocarbon. Here see that around the second carbon, around the carbon 3 methyl and one side CH2 NH2, so it containing 4 side alkyl groups, so it is a neocarbon. Then pentyne means how many carbon? Pentyne means 5 carbon, so 5 carbon is there or not? So 5 carbon, and then it containing amine, so it is the neopentylamine. The next one, tertiary butylamine. Tertiary means around the carbon 3 alkyl group means it is a tertiary. See the example, around the carbon 3 methyl is there, so it is a tertiary one, and one side amine group NH2. And but means 4 carbon, so 4 carbon also placed there, so it is a tertiary butyl amine. The next one, alpha amino propinaldehyde. Aldehyde means CHO. Alpha amino means aldehyde as a functional group. The nearer carbon is called as alpha carbon. That alpha carbon containing amine means that is alpha amine. Here that see the diagram, in that one that alpha is, which one is alpha here? The second carbon is a alpha carbon. Why it is called as alpha carbon means aldehyde is a functional group, aldehyde nearer carbon alpha carbon, so it is the alpha amino propinaldehyde. The next one, tribenzylamine. Tribenzylamine means it containing 3 benzyl, so that see the structure, it containing 3 benzene, it is a tribenzylamine. The next one, fifth one, N-ethyl, N-methyl, hexane, 3-amine. Hex means how many carbon? 6 carbon. In that 6 carbon, the third carbon containing amine. So that third carbon containing amine means N, and then the N also containing one side ethyl and one side methyl. So the structure like to be the fifth one. In this first IUPAC name, see the red color, how many carbon? 5 carbon. So 5 carbon means pent, and second carbon containing amine. So single bond is also there. So pent, ane, 2 amine. Then second one, 4 carbon is there. 4 carbon means put, and in the second carbon it containing amine, and single bond also there. So butane, 2 amine, and amine, that one side one nitrogen is attached with the methyl, so N-methyl butane, 2 amine. And third one, it is a hexane. Why it is called as hexane means 6 carbon is there, and it is a cyclic format, so cyclohexane, but one of the hydrogen is replaced with the NH2 group, so that cyclohexyl amine. Then fourth one, here I put the number. The first number goes to OH. So benzene with OH means it is a phenol, and third one containing amine. So 3-aminophenol is the IUPAC name. The next one, that nitrogen is surrounded with the 3-phenyl. So N, triphenylamine is the IUPAC name for this compound. Amine is sp3 hybridized one. In this sp3 hybridized means it contains s orbital, 1 s orbital, 3 p orbital. So totally 4 orbital. So it when during the hybridization it gives 4 sp3 orbital. Among the 4 sp3 orbital, 3 sp3 orbital they are overlap with either the hydrogen or alkyl groups, and 4th sp3 orbital it contains a lone pair electron. So the amine contains pyramidal geometry. Now that bond angle in that pyramidal means that bond angle in tetrahedral bond angle is 109.5 degree, but in ammonia the bond angle is 107 degree because of the lone pair of electron present in the nitrogen. That bond angle, tetrahedral bond angle reduced to 107 degree in ammonia. See the first diagram, it is a ammonia. In the second diagram it is a trimethylamine. In that one the bond angle is 108 degree. In ammonia bond angle is 107 degree, but in trimethylamine the bond angle is 108 degree. Why it is having that increasing means because it containing methyl group. The methyl group are repulsion with each other. Because of repulsion between the bulky methyl group, the bond angle also increases when compared to the ammonia.